Hey, Music Man.
What a nice fade out.
That was great.
Wasn't that God? That was just amazing.
Hey, we're ready to go. Look at that.
We are.
Hey, good evening, everybody. Okay. Good evening, and wasn't prepared for that. That's good. First time for everything. Okay. Good evening, everybody, and welcome to our Sunday night offering of astronomy outreach for February the 5th, the Sunday night astronomy show.
Hey.
My name is My name is Chris Kerwin. I'm the creator and admin of the social media channels known as Astronomy by the Bay. I'm an amateur astronomer and a member of the Royal Astronomical Society of Canada, the New Brunswick chapter.
Hey.
First of all, I'd like to introduce our two regular co-hosts of the Sunday Night Astronomy Show, Mr. Mike Powell from the PFO Observatory here in beautiful St. John. Hey, Mike.
Hey,
Hey.
And our other
hey,
regular host here on our program, Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton, NB.
Hello.
hey.
Hey. Oh, there we go.
All right. Gotcha.
All right. We're here.
Okay, we're good. Well, on tonight's episode of the Sunday Night Astronomy Show, now we've all heard a lot in the news lately about a particular comet, and although the views weren't spectacular with this one, it was still captured beautifully by many with its very interesting, prominently green glow. It was also interesting to know that although it's traveling at about 40 kilometers per second, it last visited the inner solar system when Neanderthals walked the Earth. There still some Neanderthals walking the Earth, but
You
Well,
think they saw it? I wonder
yeah.
if it was cloudy back then too.
probably
Yeah.
then. Now, since we still have a few opportunities to view it near some familiar celestial objects coming up, we thought it's a good time maybe to discuss some of what we know about these dirty snowballs. We'll have that discussion tonight.
Yeah.
Also tonight, Bino Bud is returning with another fine binocular target of the week. Paul will present another interesting Rosanna's fun fact for us. I'll reveal a few things to watch for in the evening sky. There's not very many in the presentation tonight. So I actually added a few facts of recent space news this week, and we'll have all of your wonderful photos to share as well. So this is a family-friendly interactive live broadcast. So for those of you joining us from my YouTube channel or Facebook page, we're happy to try and answer all of your questions here in real time. And of course, we'd like to welcome all of those who have been joining us from the local Rogers TV network. Thank you for your support.
Yes.
Okay, guys, so let's get started then with tonight's program and a deeper look at these dirty snowballs.
Yes.
I think Mr. Paul's going to carry it away with our first part of the topic.
Yeah. Well, I'm not going to get too much into a slideshow. I got a few pages that I'll share, but I wanted to look into comet history, and like when did we first start seeing them? Who discovered them? All the funny facts that happened to them, because there were some funny things that happened in the world of comets over the years. Anyway, and I'll get into that kind of stuff. So we'll just start right away. So first of all, the Greek philosopher Aristotle thought comets were dry exhalations from the Earth's atmosphere. So he thought that the Earth was burping. And then as this exhalation from the Earth went out, it would catch fire and basically giving us that illusion of a comet. And now, of course, this was many, many moons ago. So this is long before the invent of the telescopes and all that. So they could only assume things at that point. And also, they thought that similar exhalations were happening from other planets. So back in the day, that's kind of what their interpretation of comets were, which is, so obviously the only way that they saw them, they would only have ever seen naked eye comets. So anyway, so I thought that was pretty interesting. Then this fella here, I am going to share my screen on this one, if I can get this guy's picture to pop up. Yes, I can. Let me just share my screen here. Oh, try that again. Share screen. So this guy is Gottfried Kirch. And Gottfried Kirch was kicking around back in the late 1600s. And he was the guy who was the first person to actually see a comet in a telescope. That's sort of his claim to fame. But he was also a calendar guy. His whole thing was he made calendars. He actually eventually got into making telescopes. He got into doing those things. So this Gottfried Kirch discovered the first comet in a telescope for the first time in Danzig in 1667. In 1681, and Mike, you're going to appreciate this. He's the guy you can go back if you ever want to say you're wrong. He's the guy that discovered the wild duck cluster, M11.
Oh, really?
He's the culprit.
They put his telescope across the pond, saw the wild duck cluster.
Which Mike says, doesn't look like a wild duck cluster to me.
No, that's the beehive.
Oh, beehive yourself.
Yeah, it'll beehive.
In 1702, he also discovered the globular cluster M5. And of course, his claim to fame was calendar makeups. So that is Gottfried Kirch. He's kind of a cool dude.
Yeah.
Now, let's get on to this. And I don't know if I have it here or not. Just one sec. Let me just see if I can go back one and find him. I thought I started here. Maybe I didn't. Just give me one sec. Because the next one we're going to talk about, and these are a little bit more interesting comets. It's Halley's Comet. And I'll just crank up a picture so we can have a look at it as I just kind of go through a little bit of Halley Comet history. So in 1066, that wasn't yesterday, Halley's Comet, when King Harold overthrew William the Conqueror at the Battle of the Hastings, that was the first sighting of Halley's Comet. In 1456, Halley's Comet was excommunicated as an agent of the devil by Pope Calixtus III, but didn't do any good because the comet just kept coming back. So Halley's Comet is one of those comets. Of course, it's a periodic, so it keeps coming around and around. And so it's one that it's been observed for as long back as we can go and further. But I thought that was really interesting about Halley's Comet.
Yeah.
It was just one of those ones that, you know what, it's been around and it's been known for that long. And it's funny what people think. Before the onslaught of astronomy and people were starting to study what was going on in space rather than just assuming astrology and the meanings of this and that. And so it's just funny what people thought of stuff when they looked up in the sky. So that was one of the ones the Pope didn't agree with. Okay, let's go to recent times. Comet Ike-Psyche. Now this comet was the Great Comet of 1965. And I kind of remember this because we talked about this, I think, a couple of weeks ago. So I'll just tell you a little bit about this one. So the Great Comet of 1965, Comet Ike-Psyche, was discovered by two Japanese astronomers, Ike Karu and Psyche Tsutomu. And this comet was at a distance. Oh, this comet, by the way, when they discovered it, was at 290,000 miles above the sun's visible surface.
Wow,
That's not that far. How far away
No.
were we from the moon?
that's close.
Yeah, 240,000 miles.
Yeah, so
Moon, yeah.
this comet was actually pretty much our distance from the moon to us above the sun. Now, this comet, for those older folks that are watching the show, they may have seen this when they were young. I know in 1965, I was 4 years old. And this comet, you could see this comet in the daytime with the naked eye.
Wow.
That's how bright this comet was. And there hasn't been a whole lot of those since. I think there was one other one that in my lifetime that I can remember. And I think, Mike, we talked about that and we figured it was around in the 80s sometime.
Yeah. We have
Yeah.
brightest comet of all time or something.
Yeah. Yeah. Unbelievable.
Wow. I'd love to see one during the daytime. That'd be crazy.
Oh,
Yeah.
can you imagine?
I'd love to see one at night.
Well, yeah. How true.
Yeah. Yeah. So anyway, so that's just a little bit of history that I wanted to talk about with comets, because I just found, I thought these have been around so long. There's got to be some great stories, and of course,
Yeah, really.
it doesn't take much digging and you find some, right?
There used to be a saying that if you were born on Halley's Comet, you died on Halley's Comet, 75
Yeah.
years old. Right?
75. Yeah, there you go.
Scary stuff.
Yep.
I don't know. I
When
don't think.
Comet E3 comes back. How's that?
Yeah, we'll find out.
Okay, thanks,
Right.
Paul. Great
Yeah.
information.
Yeah,
Always
it's
good to
fun.
know some of the history. Don't know if anybody, David Smart said it was echoing here. You guys aren't hearing me as an echo, or?
No.
Okay, we'll make sure there is an echo. Just let me know, folks. Okay, we're gonna go from there then to Mike, who's gonna give us a little bit about the composition of comets.
Yeah, if I can see if I get the right screen here.
Is it the key to see?
So basically, this is a quick little thing I found on NASA, and it's a short answer question setup, and it says right off the bat, what is a comet? Well, comets are large objects made of dust and ice that orbit the sun. That's a comet. Best known for their long streaming tails, the ancient objects are leftovers from the formation of the solar system some 4.6 billion years ago. So
Wow.
they're old. They've been out there a while. Where do they come from? Well, they're mostly found way out in the solar system. Some exist in a wide disk beyond the orbit of Neptune, actually called the Kepler belt. These are called your short period comets because they take less than 200 years to orbit the sun. Other comets live in the Oort cloud. It's a sphere-shaped outer edge of the solar system that's about 50 times farther away from the sun than the Kepler belt is. These are called your long period comets because they take much longer to orbit the sun. The comet with the longest known orbit takes more than 250,000 years to make one trip around the sun. That's a long time. And here you can see there's the sun, there's the earth, there's the planets. The Kepler belt's way out there past Neptune. And of course, the Oort cloud is way, way, way out there. So these things are coming from quite a distance away. Then, what brings comets near to the Earth so we can see them? Well, gravity of a planet or a star can pull comets from their homes in the Kepler belt or Oort cloud. They can tug and can redirect the comet towards the sun. The paths of these redirected comets are big, like long stretched ovals that you can see here. As a comet's pulled faster and faster towards the sun, it swings around behind the sun and then heads back to where it came from. But some comets actually drive right into the sun. They don't make it all the way around and never to be seen again. Or they just melt off and turn into dust and they're gone. When a comet is in the inner solar system, or either coming or going, that's when we can possibly see them in our skies, not when they're way out in the Oort cloud. Now, what are the parts of a comet? At the heart of the comet is a solid frozen core known as the nucleus. It's a ball of dust and ice, usually Less than 10 miles or 16 kilometers across and about the size of a small town. That's still pretty darn big. When comets are out in the Kepler belt of the Oort cloud, scientists believe that they're pretty much just a frozen nuclei. They don't have a tail and stuff out there because it's so cold. But when a comet gets close to the sun and starts heating up, eventually the ice turns into gas. This can cause jets of gas to burst out from the comet and bring the dust off with it. The gas and dust create huge fuzzy cloud all around the nucleus called the coma. And you notice if anybody had a picture of this latest comet, not only green, but it's a fuzzball right around the whole nucleus before you see the tail. And why do comets actually have tails? Well, as dust and gases stream away from the nucleus, sunlight and particles coming from the sun push into a bright tail that stretches behind the comet for millions and millions of miles. When an astronomer looks closely, they find that the comet actually has two tails. One looks white and made of dust. The dust tail traces a broad, gently curved path behind the comet. The other tail is bluish normally and made up of electrically charged gas molecules or ions. Thus, the ion tail always points directly away from the sun. So if you notice the comet going around the sun, the tails are always pointed away because of the particles coming off the sun pushing it. And that's just something I wanted to show you quickly about comets. It's, what are they? What are they made of? Where do the tails come from? And so on and so forth. So quick and easy.
Awesome, Mike. Great information there.
Yes.
Okay.
Round she goes.
Yeah.
I'm going to share a little bit of stuff here that I've looked at. So we talked all about the history of the comets. Mike has given us a great description on what they are, where they come from, and what they're made out of. I'm going to look back at a table that we've seen maybe before, but I'll introduce it again.
Dinner table?
Well,
Card table? Comet table.
comet table. Where's it at now? It's on that screen. We didn't open the time. Hang on a second. What was that? Let's try it again. There. Okay. So with the information that Mike offered is information like this that's available on websites like heavens-above.com. So on the website right there now, they're saying that comet C22 2022 E3 ZTF. A little bit about the name too. The C means it is what we call a non-periodic comet, which means that it's going to take more than 200 years to orbit the sun. The 2022 is the time when it was discovered, so the year 2022. The E means that the months are actually broken up into two parts. So A, B would be January, C, D would be February, E, F would be March. So this E means it was discovered in the first half of March of 2022. And the 3 stands for the third comet in the first half of March of 2022 that was discovered. So that's what this designation means now. You can see a lot of these say ZTF, Pan-STARRS, Atlas. These are observatories, large telescopes that are constantly panning the sky, finding these objects that are way out there when they're even a magnitude 18, something that would not be visible for us locally at all. But they're panning way out there looking for comets, and they're finding them more often than, say, amateur astronomers are. Back in the day, amateur astronomers were they had their names like Shoemaker Levy down here attached to them because they were the ones who discovered them first. But now, because of these huge telescopes out there, again, scanning the sky all the time, they're picking up a lot more of them. So amateur astronomers getting them named is becoming more rare, actually. From there, if I went to any of these comets listings, we can see here's the brightness, and I'm going to talk about the brightness here in a second. The last reported date, the angular separation, altitude, how high it is at that particular time when I punched in the time I was talking about, and the constellation that they sit in. So right now, E3 is in Auriga. Here's a chart. So if I clicked on the first link there, this would give me the chart. This is for February 5th, and the time is 9 o'clock tonight. So there's where it's located within that square, 9 o'clock tonight. Now that's a field of view of It says 60 degrees. I don't know if it's 60 degrees, is it, guys? 60
degrees,
degrees.
I didn't
Yeah,
think so, but
that seems like a big area.
oh, the whole picture maybe, not the box.
Yeah, maybe the whole picture. Here's the finder chart. So there it sits right there, right beside the star Capella in Auriga, which is the sixth brightest star in the sky, and the brightest star in the constellation of Auriga. This view here shows you from looking down on top of the plane of the planets, the direction of the comet, going in that direction right now. And here it is from the comet's view of our plane of our planets. So you can get these four views if you punch into that Heavens-Above website. So you go to that website, on the top right-hand corner, there's a spot where you would type your location, or you can go partway down the page and select it down there. And then you just click update and go back to the page, and it'll have your information stored on the page. You'll be in the database then, and you can find out a lot more about these comets. So we're talking about this comet. Actually, it was saying a magnitude 6.8 on Heavens Above page, but another page I'm going to show you looks like it's about 5.3. What does that mean? Well, anything above magnitude 6, brighter than magnitude 6, is your naked eye limit. And the numbers go backwards. And there's a reason for that because of, oh, we can get into the talk later. But just believe that the numbers are actually going in the other direction. The minus number down here is where the sun sits. Then you have the full moon at about minus 11, minus 12. Venus at its brightest is around minus 4.5. There's the bright star Sirius, the brightest star in the sky. It's about a minus 2 or so. Polaris is sitting about a plus 3. Naked eye limit is about a plus 6. And the Hubble Space Telescope can see about a plus 28 or so, magnitude 28. So what does that mean? So magnitude 6 is a naked eye limit. So each of these numbers, by the digit of 1, changes the value at 2.5 times, and it's logarithmic. So magnitude 5 star is 2.5 times brighter than a magnitude 6 star. A magnitude 4 star is 6.25 times brighter than a magnitude. So that'd be 2.5 times 2.5. And we go down the chart here, magnitude 3, 15.6 times brighter than the magnitude 6, 39 times brighter, 97 times, and 244 times brighter at a magnitude 0. So we're working this way to the left. So that's the scale. So we were looking at a magnitude 6.8, which is above the naked eye limit. So you're going to need some kind of optics to be able to see it. Even at that, a comet is a larger body, I'll say, than a star from a distance, because a star is a pinpoint of light, and comets are closer, but they've got not as much light, and it's spread out over a larger surface area. So by the time it gets to our telescopes or our eyeballs, it's a lot dimmer. That's why we need optic aids like binoculars or telescopes to improve the light level. Telescopes and binoculars aren't really about magnification. They're more about the fact of capturing photons. The bigger the optical tube, the more photons of light it can capture, especially for our eye, because our eyes are instantaneously looking at something. We can't collect photons like they can on the camera chip. So it's important to have something with larger optics to see when you get down above magnitude 6. Okay, so from there, here's where we're going to see the comet now over the next little bit. So here we are tonight at 9 p.m. So the comet is very close to Auriga, not very close in realistic terms, of course, but in our night sky, it's sitting pretty close to Auriga. So actually, Capella and the comet would sit together in the field of view of binoculars tonight. So if you're having trouble finding the comet, find the bright star Capella, which would be just well, it's almost directly above Mars. And you'll see that star very bright, and try binoculars trying to get the two of them in the field of view. And that's a good indication of where you're going to be able to find it tonight. Tomorrow night it's down around here. Then by the 10th, it sits down here next to Mars. So there's another good target to be able to have the two of them in your field of view of 10 by 50 binoculars. So that's about 7 degrees of sky, which would give you the comet and Mars together. So that would also be an opportunity to grab an image of it, maybe a photo of both, because Mars is fairly bright, but the comet's dim, but it might blow out Mars a little bit, but that would still get the two of them in the same eyepiece. From the 10th There's a closer view. So there's where it sits. And that's only about 1.5 degrees right there. So very close. There's the Pleiades star cluster for another marker for you. This is the star Aldebaran. That's on the 10th. And here we are on the 13th. So a few days later, the comet's moving down this way. We can see here, we're getting close to the star Aldebaran at that point. And on the 14th, it'll drop down into here, which is very close to the Hyades star cluster, which is inside the horns of Taurus the Bull. There's that bright red star Aldebaran as well. So, or orange star. So it'll drop down this way from the 13th through the 14th, 15th. Getting dimmer each night, but still you've got a few targets in here that you can shoot for to try to find it. It's better than having the way out here in the open sky and trying to describe how to get to it that way. Here you've got a nice few targets.
That Chris too, like on that date when it's between Mars and Aldebaran, all you got to do is find those two bright orange things in the sky because they are very colorful even to the naked eye.
Right. Yeah.
Those two things, and it's almost all the way to Aldebaran.
Yeah.
So because they're going to be about the same, close to the same brightness, aren't they? Mars and Aldebaran.
They will. Yeah. Yeah, and so we got Mars, the Pleiades, and Aldebaran. Even if you want to make a big triangle out of the three of them.
There. Yeah.
And there's just off to the side of that. So that's a good marker. And again, over those few nights, the 10th, 11th, 12th, 13th, 14th, 15th, all the way down through this area. So it's going to pass very close to the Hyades as well. And next to Aldebaran, I think on the 14th, it's out like here, kind of this area in Aldebaran. So you still get some nice opportunities to catch it close to a target with some clear sky. I can't guarantee that part.
Yeah.
Okay, so that's that part. I did want to stop sharing for a second. And I'm going to close that window because there was something else I wanted to show. So I'm going to open my window up again, share the screen again. So here's another way that we can learn something about it. This is a fantastic page. It's called the Sky Live. And what it does is it offers a lot of information about targets. So you can go to major object comets, asteroids, near Earth objects, whatever, all the way down through. Here's our information about comet C22 E3 ZTF. So it tells a little bit about it, where it is. It's in the constellation of Auriga right now. It gives a right ascension declination. So if you're using a telescope, how to find it. There's your coordinates. In other words, its observed magnitude right now 5.5. Estimated from JPL is 8.23. Visibility right now, it'll tell you if it's above the horizon or not. And you can change your location here, where you are located. It'll tell you if it's above or below the horizon. Down the page farther, here's a nice star map. Nice detailed star map. There's Perseus, and there's Auriga. There's this bright star Capella, and look at how close it is. So that's tonight. And there it is even better. There's an even closer view. So it's called theskylive.com. So I just typed C 2022 E3 The Sky Live, and it brought me to this page. There it is in the sky with a lot of stars around it, deep sky chart. And here it is showing its brightness, how bright it was expected to get and how it's expected to be over the next, I guess, up to 2028. So we see here, January 2023, got its brightest down here. They expected it to be around 0, but it wasn't quite that bright. The distance in kilometers or astronomical units. And then they've got this one, the rise and set times of it. And I'm sorry, that was the closeness. That's where I was wrong. Yeah, this is how close it was right here. And the next chart was actually the brightness. There's the brightness. So it didn't quite reach magnitude 5 or 4. Down below, it gives us a nice little 3D animated. I'm just using my mouse here to squirrel around so I can see where the comet is in relation to the planets. All kinds of views from above and below, and so it places it better for me if I want to get a better description of where it is. And then this is all the ephemeris of its location, where it's going to be over the next number of days, and the constellation that it sits in. So it's in Auriga right now, right up till the 12th, and that's as far as I go. It actually moves into Taurus on the 10th. Yeah. So lots of information on that page. I like this one. I found that kind of by accident, but kind of glad I did. So there's lots of ways to find out about what's happening with comets over the next little while. And
we just got to make the clouds go away so we can see them.
that would be
That's
great.
it. Got to get it.
It's also a celestial event, so you have to, you're guaranteed clouds with celestial event.
Well, there was a balloon that came across the States and it was going to knock out all the clouds, but they shut it down.
Yeah.
It was full of comet.
And it landed in the tide.
At dawn.
Okay, guys, you can carry it away.
Oh, that's funny.
Okay, that's a little bit about comets, the history, the composition. Where to find this one for a little while yet. We still have a few opportunities. Like, you know, tonight if you're out and you had a clear sky, you'd have it near Capella. It's going to be down around Mars, down around the Aldebaran. Those are easy targets to find in the sky. So you still have an opportunity if you get a nice. The larger the telescope, the better your view is going to be for sure. So anyway, that's a bit about comets. Let's go from there maybe to albino bud.
That was a bit of a long tail, wasn't it?
That was a bit of a long. Boy, it's getting worse. Hurry up, Mike.
Let's go from naked eye comets
I dropped
to
my pen.
naked eye objects we won't be able to see with binoculars because of the weather. All righty. So binocular target of the week this week by Bino Bud is, and anybody that's got some age behind them will know this, Campbell's Cascade.
Ah, yes. Yay.
And it's an awesome target.
That's a great target. Yep.
No pun intended. Campbell's Cascade is an asterism located in the constellation, here we go, Camelopardalis. How's that?
Camelopardalis.
Yeah, close enough. It's a apparent straight line of more than 20 colorful 5th to 10th magnitude stars over a distance of approximately 3 degrees or 5 full moons in diameter. And I'll show you that one at the end of the slides here. It appears to flow into a compact open cluster NGC 1502 that can be found at the end of the line. So how do I find it in the sky? Well, if it was clear tonight and you could go out and see those stars, about 9 o'clock, orient yourself almost due north at 345 degrees north-northwest. And that's almost, there's north right there, that green line, almost straight up. And you will find that Camardo-Pallia, that one. An easy way, yeah. And between the top 2 stars of that triangle, you'll find NGC 1502. And if you can't find it that way, you can look up, see the W of Cassiopeia and draw a straight line between the 2 top stars, and drag it on, and it'll bring you right to it. A little bit of a closer look. Again, you can take a line, draw right through those 2 stars in Cassiopeia, and it'll bring you right to that NGC 1502. And that's right at the end of Campbell's Cascade. So once you find that, you'll see the cascade. What is it there? What will you see? Well, you won't see the beautiful colors in this, but look at that line of stars. Almost a perfectly straight line, and the colors are phenomenal when you photograph it.
Yeah.
But in 10 by 50 binoculars, there's that straight line. Look at that. And I mean, it looks perfectly straight. And then it pops off a little bit, and you see that NGC 1502 just up off to the side of it. So it's real easy to see in 10 by 50 binoculars. Again, compared to the full moon, it's got to be 5 full moons in length. So it's a big target, easy to see. Like I say, in 10 by 50s, it takes up half your screen or half your field of view. So it's an easy target to find. And when you do see it, it's awesome to look at. And in today's world, take us to your, it's just the way it is. And that's Binocular Target of the Week by Bino Bud.
Awesome.
So,
Thanks, Mike.
to pronounce that, Mike, this
Yeah, Camel.
Camelo.
Camelo.
Camelo. Remember Camelo?
Camelo.
Camelo. Pardalis.
Isn't that Charles,
Pardalis.
the Queen there? Camelo?
Yeah, kind of the same.
There you go. Camelo Pardalis.
Camelo party less?
Pardalis. Pardalis. Camelo Pardalis.
So she likes to party less. Camelo party less.
Try Zubin al Janubi, like Kurt likes to say. Try Zubin al Janubi.
Yeah.
Yeah, that's a hard one.
I go to Google Pronounce, I listen to it 25 times, and then I completely forget it.
By the way, in terms of your magnitude stuff, Chris,
Yep.
You see up to a magnitude 9 with binoculars.
Yeah, right.
Yes.
Yeah,
So
make
naked
six,
eye
naked eye.
up
So,
to
yeah.
6, and then from 6 to 9, you can use binoculars to see it. So binoculars for that target would be very, very easy.
Yeah.
Oh, yeah.
At a 5.3 right now, so it should be able. And again, if you're near Capella, you'd be able to get up great tonight.
Yeah.
Tomorrow night it's going to be a little bit farther away. Tomorrow night is calling, I think, for clear sky tomorrow night locally. So you can pick it out tomorrow night too, just be a little bit farther away.
Yeah, the only killer is you got pretty much a full moon there.
Yeah, that's right.
Yeah. I remember in Fundy, we used to stand there and look at the Kimball's Cascade.
Yeah.
I think you introduced it to me, Mike.
Oh, it's gorgeous to look at.
Oh, naked eye.
Yeah.
It's just, it looks like something coming down off the bottom of Cassiopeia.
Yeah.
Like I said, it looks so straight. You can take a ruler. Those lines, it's a perfectly straight line of stars.
Yeah, it's one of the nicest things you'll see.
It's one of the nicest things with binoculars for sure.
Yep.
Okay. We'll go from there maybe to a what's up talk. What's up talk? There's
no, Party Alice.
There's not a whole lot to talk about in the what's up because there's not a whole lot. What's up this week?
Clouds.
Clouds.
That's the clouds.
Lots of them.
That too. Let's go over here from the beginning. I got to flip the view here. Display settings.
But a plus side of everything, it's getting warmer at least.
It is absolutely, yes. Okay, so what's up this week? Well, that's just a little bit of the path of the comet over the next little while, so we can see how it's traveling here from Auriga, Camelopardalis. There's the Camelopardalis.
There's a camel, yeah.
Down through near Mars here on the 11th, I guess, and straight on through Taurus. So spends a fair amount of time in the Taurus area. Anyway, looking south tonight, here's our southern sky this evening. So that yellow line that we see going through our image here is called the ecliptic. That's the path that the sun and the moon and the planets tend to take across the sky. You're looking along that line, imaginary line, and you see something like this, and you're wondering, is that a star or a planet? Well, if it's a solid ball, not a point of light, and it's not flickering, it's probably a planet because it's following the ecliptic. That's the path that they take across the sky. So the ecliptic is still a little bit, it's actually quite steep over here in the southeast when the moon rises. So the moon's up about an hour later each night now. Along with that, we've got Orion, still the prominent constellation in our sky. And up in this corner, we have Pegasus, which is the other prominent constellation. We make most of the winter circle here as well. There's Canis Major, which has the bright star Sirius, Canis Minor, Castor and Pollux, Capella, and then back over to Aldebaran and Taurus, and down to Orion, Rigel, and that makes our winter circle. From Pegasus here, this is a really kind of an easier target once you find it. Then you just count out 2 stars and up 2 stars, and you're going to hit the Andromeda galaxy right in here if you want to pick it out with binoculars.
Well, there goes next week's target.
Okay, well, you get another one. And there's the W of Cassiopeia. That also points, the second V points straight down to it too. So if you can't find it this way, try the second part of the V. It'll end up right there as well. Down in Taurus, of course, Taurus and Orion are really interesting. You have the Orion Nebula down here in the corner. You've got really blue-white Rigel down in the, I'll call it the left-hand foot. And the right shoulder is Betelgeuse, however we like to refer to it. Follow those 3 stars from the belt. They go straight up into Aldebaran and then on into Perseus. If you go this way, from the bottom left to the top right, you'll end up at Gemini. Straight up this way takes you to Auriga. So there's Orion, becomes our signpost. Straight down takes us to the brightest star in the sky, Sirius. There's Taurus, which is there's a constellation of Taurus, which has Aldebaran, that orangey star sitting there, kind of rivals Mars as far as color goes. So there's still lots to see with just binoculars. Out here is the Pleiades star cluster, just across from Mars. So that's a beautiful cluster in binoculars. It's actually probably best viewed in binoculars, better than a telescope for sure. Beautiful blue-white stars in there, about 100 million years old, just little baby stars, little stellar nursery. So we have a stellar nursery here. We have another stellar nursery down in here. And then we have the Heidi star cluster sitting in here. So you've got lots of targets out there for just binoculars. And well, try Andromeda up in here. Of course, you've got Jupiter and its moons as well. Bright Venus. Venus is climbing each night now, getting closer to Jupiter. Jupiter's falling each night. So the two of them are going to come up to a really nice close conjunction. They're going to appear like one planet, really, in the sky on March the 1st. So we still have Mars for quite a while yet. Saturn has now set out of the way, but we'll lose it until early summer. Okay, from there, let's go to over the next 2 weeks is what we call something called the zodiacal light. So there's a cone of light that appears in the western part of our evening sky just after dusk at this time of year. That cone is known as a zodiacal light. People used to think the zodiacal light originated somehow from phenomenon in Earth's upper atmosphere, but today we understand it as sunlight reflecting off dust grains that circle the sun in the inner solar system. Now, these grains were once thought to be left over from the process that created our Earth and the other planets of our solar system 4.5 billion years ago. Now, in recent years, though, there has been discussion about their possible origin from the dust storms on the planet Mars. That's pretty cool. That's really visible. You're going to see this very faint cone of light, almost like a pyramid of light in the western sky in the spring. And it's best visible when the moon is out of the way, of course. So you're hopefully going to get that coming up soon as well as we pass the full moon phase tonight. There's another again for Monday's February 6th comet view on Monday evening. Look west at 10 p.m. Atlantic time for a view of comet. Comet will appear within a binocular view of the bright star Capella in Auriga. Capella is the 6th brightest star in the night sky. Later, from the 10th until the 14th, you can catch the comet passing near Mars and in front of the Heidi star cluster in Taurus. A couple of things happening with Jupiter this week. We have a couple of shadow transits. So Jupiter is still prominent in our evening sky, the 4th brightest object in our night sky, or in our sky, I should say, altogether. On occasion, we can witness a mini solar system of sorts as the Galilean moons orbit the giant world. And occasionally, we'll get to witness one of them passing in front of Jupiter from our point of view. Now, when this happens, it usually allows us to witness its shadow traversing across the planet as well. This is called a shadow transit, and we have a chance to watch it happen Monday evening as the ice world Europa performs a shadow transit. Now, this takes place between 1744 or 5:44 p.m. and 2009 Atlantic time. So lots of time there to see it, 3 hours. And it does just look like that. It looks like that little black dot that's sitting there on the surface. On Friday the 10th, another transit comes up, Io shadow transit. We have at least one extra opportunity to check out shadow transit this week. You can look for the shadow of Jupiter's moon Io as it traverses the giant world on Friday evening, beginning at 1801 and ending at 2012. So a couple hours there. And you'll also get to see a few of the other moons. Ganymede, the largest moon in the whole solar system. Callisto is the most heavily cratered moon in the solar system. Io is the most active moon in the whole solar system, and Europa, of course, is a giant ice world with a global-sized ocean underneath the ice. Now, since we don't have too much to talk about what's up in space, we're going to take a little look at what's new in space. So I might add a couple of slides of this each time we do a presentation. First of all, hey, 12 new moons around Jupiter. Astronomers have discovered 12 new moons orbiting the giant planet Jupiter, bringing the total now to 92. That's more than any other planet in our solar system. Saturn, the one-time leader, comes in at a close second with 83 confirmed moons now. The Jupiter moons were added recently to a list kept by the International Astronomical Union's Minor Planet Center. Now, they were discovered using telescopes in Hawaii and Chile in 2021 and 2022, and their orbits were confirmed with follow-up observations. So Jupiter is the king.
There you go.
Now, also, astronomers have discovered a potentially habitable exoplanet only 31 light years from Earth. Only. Although astronomers have discovered more than 5,200 exoplanets so far, less than 200 are actually rocky. So the discovery of a new terrestrial exoplanet is always exciting. Excuse me. And in a new study, a team of 50 astronomers from around the world have confirmed the existence of exoplanet Wolf 1069b, which orbits a red dwarf star, Wolf 1069, only 31 light years from Earth. But what makes this discovery particularly intriguing is that Wolf 1069 is potentially a rocky world at about 1.26 times the mass of the Earth and 1.08 times its size. So very close to us. Wolf 1069b also orbits in its star's habitable zone, making it a prime candidate for liquid water to potentially exist on its surface. The only thing about these stars, though, when they're talking about dwarf stars like this, the fact is that the planet has to orbit closer to the star for liquid to be on its surface, so it can be affected by radiation from that star. But I know they know all that stuff anyway. Anyway, kind of neat to see the discovery of it. So here's a little time lapse, kind of neat. New time lapse video shows 12 years of exoplanets orbiting a star. Now, in 2008, HR 8799 was the first extrasolar planetary system ever directly imaged. Now, the famed system stars in its very own video. Using observations collected over the past 12 years, Northwest University astrophysicist Jason Wang has assembled a stunning time-lapse video of a family of 4 planets, each more massive than Jupiter, orbiting their own star. This video gives viewers an unprecedented glimpse into interplanetary motion. HR 8799 is a compact star located about 133.3 light years away from Earth in the Pegasus constellation. Although this seems unfathomably far away, HR 8799 is considered within our, quote, solar neighborhood. Compared to our sun, HR 8799 is 1.5 times more massive and roughly 5 times more luminous. It is also much younger, at around 30 million years young. The system actually formed after the dinosaurs went extinct. So that's pretty cool.
Wow.
So directly imaging planets now.
There you go. That's awesome.
Oh, we're getting close. Also, Perseverance completes a Mars sample depot. So there's a Mars sampler right there. On January 29th, NASA's Perseverance Mars rover successfully deposited the last of 10 planned sample tubes onto the Martian surface, completing the first sample depot on another world. The tubes, capturing an amazing variety of Martian geology, have been deposited on Mars' surface so they could be studied on Earth in the future. The titanium tubes were deposited on the surface in an intricate zigzag pattern, with each sample about 15 to 50 feet or 5 to 15 meters apart from one another to ensure they could be safely recovered. When will they be retrieved is not known yet, but plans for a future recovery mission are ongoing. So that'd be cool. It just picks up the samples and drops them.
Cool.
Leaving its deposits on the planet. Lisa's lookup. Now, Lisa, I try to refer to this chart every week. I go to this as well when I'm putting my What's Up talk together. Lisa has a great chart here. You can find her at Lisa's Lookup, Astronomy and More. You can find her at Ruby Moonbeams on Instagram, Twitter, Mastodon, and Facebook. And what Lisa does is she lists all the celestial events coming up for the month. She lists the dates that they're going to be available, the times when you best to see them, and whether you need naked eye binoculars or a telescope to see them. So she does a great job in this chart every month. I look forward to it. Again, you can follow her at Ruby Moonbeams on Instagram, Twitter, and Facebook. And we have our St. John Astronomy Club and Royal Astronomical Society of Canada, New Brunswick chapter, our February-March calendar. This calendar is available if you go to sjastronomy.ca. It's right there on the page. You can download it. I picked up this one today, so this gave me my February-March look ahead. So it gives you all the events that are happening that are of any significance at all for the next month and a half. And that's about all we got for our talk on what's up this week.
I want to mention something too on, you were talking about the shadow transits. And you have to have a 6-inch or larger telescope to actually be able to see those.
Shadow transits?
Yeah, on Jupiter.
Okay.
Yeah, it's got to be at least 6 inches to be able to see a shadow transit. You're not going to see it in binoculars.
Yeah, right. Exactly. Okay. We're good from there. Paul is going to present a Rosanna's fun facts next, I guess.
Sure. All right, let me see if I can do this. I got a missing screen tonight, so this should be interesting. See if I can pull this off. All right, so
It's kind of like not having your phone.
it's this is really weird because I've never had to balance it, but we're going to try. I don't even know what you're seeing. What are you
They're
seeing?
seeing a field,
A field?
Hmm.
with a whole bunch of shortcuts.
Okay, that's not what I want to show. Let's try this one.
There you go.
Roseanna's fun fact.
All right. Now, before I do that, I got to pull this over here, then make this bigger, and then I got to make this. I got a lot of juggling to do with this, so that's not what I wanted. Oh my good golly, Miss Molly. There, I'll find it eventually. There it is. Okay, I can shrink that, make that larger, Mr. Pig. There we go. And now we're ready for
Rosanna's Fun Fact.
Hey, this is when you're so used to having things and then they're not there anymore. You know what?
Oh, that's okay.
I was able to bounce the ball down the court and put it in the net. So you know what? We did it.
That's
And
okay.
it's good that I did, because this week's Rosanna's fun fact is this one's a really, really cool fun fact. That's going to be a lot of fun to do. So here we go. So she says, so let's talk about clickbait. Now that's a word that carries a connotation of ugh, but it is definitely part of our everyday lives. Bait is a rather unpleasant word in almost any usage because it conveys at the end result of trickery. Fish bait, don't take the bait, and so on. One might think that clickbait is a recent invention, and it is relatively. It was coined in December of 2006 in a blog posted by Jay Geiger. Let me just actually see if I can make that picture pop up. There we go. By Jay Geiger, and it made it into the Oxford Dictionary in the fall of 2016. But in truth, clickbait has been around. Has been much longer history. In the late 1800s, a thing called the yellow journalism developed, where ridiculously printed headlines or a crazy comic strip like Yellow Kid, thus the yellow journalism, encouraged the purchases of newspapers. And according to an article in Gizmodo, that word alone inspires no confidence. So that's kind of where it started. So the U.S. State Department maintains to this day that yellow journalism helped instigate the Spanish-American War. So it's interesting to consider that over a century ago, Hearst and Pulitzer's newspapers were considered largely yellow journalism enterprises. And yet now Pulitzer's name adorns the Pulitzer Prize, one of the most respected honors any journalist can receive. To get the full course of this irony, imagine that in 50 years, the most important award in journalism is called BuzzFeed Prize or Gawker Award. That's so funny. So maybe it's been around even longer. Clickbait Moses. Thou won't believe these 10 hashtag life hacks to avoid eternal damnation. Oh well, enough said. This all leads to a clickbait headline that captured one of my brothers, and he sent it to me, and it's well worth the click. News, January 26, 2023, weird supernova remnant blows scientists' minds. And yes, that headline would certainly catch your attention, especially with this picture. So what are we actually looking at? So this is a PA30. MA has gone missing. In 2013, amateur astronomer Dana Patrick discovered the object in the archived images from NASA's Wide Field Infrared Survey Explorer. Over the next decade, several teams studied the remnant known as PA30, but the results became only more and more baffling. Now, why dying stars explode as supernova, they usually eject a chaotic web of dust and gas. Here we have a glorious picture of the Crab Nebula, which is a more standard example of a supernova remnant in which a dying star ejects a crazed web of gas and dust. And on the other supernova remnant, we have Tycho supernova remnant, which looks like a bad hair day after a motorcycle ride with no helmet. So this image actually came from the very deep Chandra Observatory of the Tycho supernova remnant, produced by the explosion of a white dwarf star in our galaxy. So what's up with PA 30? Who doesn't like all that regular supernova? In 2019, Vassilini, I'm not going to say the last name, an astronomer at, I'm not going to say that place either, in Moscow State University in Russia, and his colleagues found an extremely unusual star at the dead end center of PA 30. That star had surfaced temporarily of roughly, or sorry, that surface had a temperature of roughly the speed of light, 200,000 Kelvin, with a stellar wind traveling outward at 16,000 kilometers per second, roughly 5% of the speed of light. Stars simply don't have 16,000 kilometer per second winds. Speeds of 4,000 kilometers per second aren't unheard of, but 16,000 is wild. Considering a speeding bullet travels at 1,800 miles an hour, twice the speed of sound, 16,000 kilometers per second is hard to imagine. Below is a view of Pan-STARRS, PA 30, and PA 30 was again the subject of intrigue in 2021 when Andres Ritter, an astronomer at the University of Hong Kong, and his colleagues proposed that the remnant is the aftermath of a supernova that lit up the sky nearly 850 years ago in 1181. Chinese and Japanese astronomers observed the object for roughly 6 months before it actually faded. So basically, astronomers have solved a 900-year-old mystery surrounding the origins of a supernova, first spotted over China in 1181. A faint nebula called PA 30, pictured in 3 different images with colors showing X-ray emissions, has been identified as a 12th century explosion source. So you can see with that type of a telescope, they are looking for heat, and obviously as it fades away, it gets darker. During the experimentation of PA 30, Ritter and his colleagues noted that the remnant's emission spectrum contained a particular line associated with the element sulfur. Intrigued, Fessen's group later imagined that the remnant, with an optical filter that is sensitive to that line using the 2.4 meter Hiltner telescope in the Michigan Dartmouth MIT Observatory at Kitt Peak in Arizona. This is a quote: "I have worked on supernova remnants for 30 years and have never seen anything like this," unquote, says Robert Fessen, an astronomer at Dartmouth College in Hanover, New Hampshire, who imaged the remnant late last year. He reported his findings at a meeting of the American Astronomical Society on 12th of January and posted them in a not yet peer-reviewed paper on the same day. The data that they collected confirmed that PA 30 is indeed what's left of the supernova observed in 1181, and also yielded that very eye-catching and unusual image of PA 30. Now, although sometimes an errant click can send one on a sketchy path, this click was well worth it. Already, Fessen, who took the sulfur filter image, has applied for observing time on both Hubble Space Telescope and the newer James Webb Space Telescope. The optical image that was taken, I think, gives only a hint of what it really looks like, Fessen said. But with the James Webb Telescope image will simply be amazing. So further investigation of this unusual remnant, more astonishing photos of PA 30 are in our future. I'm still wondering where in MA is. I wonder if we should click on that.
Wow.
That is amazing. And that is this week's.
Zen's Fun Fact.
Hey!
There we go.
Nothing to show here.
Much, Roseanne. Well, there's a glitch we can put in our future bloopers.
That'll go in our bloopers. That's going in the blooper reel, no
But
question.
anyway, isn't that interesting, eh? It's
That's
amazing.
different, yeah.
When we're thinking about what at the top of the show, we talked about how people observe the sky without any technology. And now we're using technology to look back at what they discovered back then to even confirm more things. It's unbelievable.
I wonder how many of those things are still out there as mysteries that we had looked at and they're going to
Yeah.
go back and do more detective work on. Yeah.
I'd be excited to see a supernova that would light up in their daytime for 6 months.
Yeah. Yeah.
Yeah.
Crazy to see.
Yeah. And then on top of that, the fact that clickbait has been around forever in those yellow journalism.
That's right.
So anyway, very, very interesting fun fact tonight and a lot of fun and very timely. So
Oh yeah, always.
Awesome. Thanks, Rosanna. Once again. Another amazing presentation. Okay, we're going to get quickly to some photos now, I guess.
Yeah.
Oh, before you do quickly, I
Yeah.
want to just put out a quick shout out. I don't know who it came from and I don't know where it came from, but an envelope showed up in my mailbox. And when I opened it up, it's a single clipping of a comic cut out of a newspaper of a flying saucer comic joke. And again, I don't know who sent it to me, and I don't know where it came from because there was no return address, no nothing. But it's hilarious that somebody took the time and cut this out of a newspaper and sent it to me. So thank you very, very much, whoever you were.
Yeah.
sir.
I don't know. Kim was supposed to bring it up and drop it on my desk, but she forgot. But I said I'm going to give the call out either way. So
We're all curious now.
Yeah.
I'll have it for next week. I'll show them.
Next week. Tune in next week.
I had to chuckle like, who does that?
That's awesome. Don't
Okay.
lick it. Don't lick it.
Go ahead. Yeah. Let's go to a few photos.
Oh, nice.
This one's from Emma. Emma says our star, Mapleton Park, February the 2nd. Yeah.
Yeah, looks chilly.
Looks chilly. You're right. Very nice. Thanks, Emma.
Yeah, beautiful.
Audrey, now I'm going to have to zoom these in a bit. Audrey
Oh,
Zanoika,
nice color.
Zanoika said this one.
Oh,
She said, good morning. I am attaching a few photos taken on January 30th in Maces Bay. She says, thank you for all you do for the astronomy community. Learned so much from your Sunday night astronomy show. Well, thank you for
Beautiful.
tuning in. Audrey, very nice shots. Another one here.
oh wow.
Oh, nice.
Yeah.
Right out of the clouds, eh?
Yeah.
Yeah.
There's a moon capture too. So
Nice shot.
very nice.
Very nice.
Thanks, Audrey. I'm going to go from there to Matthew Dupre and Matthew's image of the Rosette Nebula.
Yeah, he did a heck of a job on that.
Yeah, terrific.
But an hour he spent on it. So yeah,
Yeah, beautiful.
it's amazing to.
Oh, well done. Very well done.
Yep, looks
That's
really
detailed.
good. Nice cluster in the middle of that. That's just beautiful, beautiful thing to look at.
You can say he's come a long way.
Yes, yeah, absolutely. Great job, Matthew. Thanks for that.
Beautiful.
Denise Gauthier was out with her. Caught this one of the Jupiter and its moons.
Yes,
Yeah.
sir.
Nice.
Hey, Denise.
All 92 of them.
Yeah. That was on Saturday night. Sean Lynch capture from Friday night.
Right on.
Nice, Sean. And Barb Murray took a couple of pictures from inside the house. She said,
I
don't blame
don't
you,
blame
Barb.
her.
Right
I don't
above
blame
the
her at all. There's
big
Kathy Adams is a shot of.
Yeah,
her
beautiful
well.
shot, Kathy.
Yeah, nice shot.
That was cold.
That was
Real,
cool. Yeah,
real
for
cold.
sure. Yeah. This one's from Lisa Fanning. Lisa, grab this
Yeah.
one. She's
Thanks,
waxing
Lisa.
gibbous moon on the 4th at 6:28 p.m. Eastern time, almost full. Looking beautiful tonight, she says. It is warming up here in New Jersey. We are currently at 21 Fahrenheit with feels like 12 degrees Fahrenheit.
Right
So
on.
iPhone 13, Celestron Nexstar Evolution 8, and a 40mm eyepiece. Well
There you
done,
go.
Lisa.
Well done.
Patty Malkawain sent this one in, shot this very quickly Friday, February 4th, handheld Galaxy S22.
Yes, sir.
Nice.
Yeah, the phones can do, eh?
Yeah. I know I'm skimming through these a little quick. I know we're running a little bit late on time. So
Oh, no worries.
David Hoskins, Messier 3.
Three, yeah.
Social fan.
Hoskin, sorry. Mesquite globular cluster located in the constellation of Canis Venatici. It contains about 500,000 stars and is thought to be about 11 billion years old. Distance from Earth, 32,600 light years. It was captured on February the 2nd from Halifax with a ZWO ASI 533MC Pro and Optolong L Pro filter on a Celestron Omni XLT 150 reflector, a Skywatcher EQ 6R mount. Subs, 24 8-minute subs plus calibration frames were stacked with Deep Sky Stacker, post-processing using Serial, Photoshop, and Microsoft Photo.
Yes, sir.
Nice capture.
And this one of the Comet, said my latest and probably last, given the weather forecast for the next week, image of Comet C 2022, captured on the evening of February the 1st.
Right on.
Well, nicely
Here it
green.
is. The green
Yeah,
one.
the
green
slowly
comet.
getting dimmer.
Yeah, it is.
Yeah.
And another one here, Wax and Give Us Moon, image last night, he says. So
Beautiful. Nice detail.
shot. Yeah, lots of detail on that one.
Very nice.
Just love those and just looking around. Just nice to be able to have one of them pan around.
Yeah.
Mr. Owen,
Oh, yeah.
too cold to actually go out, but looking through the window is just fine by me.
Hey, it works.
Worked, yeah, sure did. Great shot, Paul. Nicely done.
Was that song by CCR, Looking Out My Back Door?
That's it.
Oh,
Yeah.
Bad Moon Rising.
Bad Moon Rising, that one too,
There
yeah.
you go.
And this one from Mr. Powell.
Oh, that was cold.
Yeah. Minus 24
Even the
degrees.
stabilizer wouldn't help that one.
Yeah. Awesome, Mike. Good shot.
Okay.
96.2% visible. 2 days left to the next phase of full moon. So we are there now.
Yep.
And this one coming from Renat.
Here's the
so they
bar.
said- there it is. So there's a bar on the moon, on Mars.
Bar on the moon.
The bar on Mars.
Or Mars, yeah.
Scientists found an unexpected discovery on the surface of Mars, a formation resembling the face of a bear. A camera on NASA's Mars Reconnaissance Orbiter snapped a photo of the formation on December the 12th. Now, the University of Arizona, which operates the camera, shared the image on Wednesday. Two beady eyes are formed by two craters. A hill with a V-shaped collapsed structure resembles a snout. A circular fracture pattern outlines a head. The circular fracture pattern might be due to the settling of a deposit over a buried impact crater. University of Arizona's Lunar and Planetary Laboratory says, now maybe the nose is a volcano or a mud vent, and the deposit could be just lava or mud flows. But still looks like a bear to me.
Now, you go back to any one of those full moon shots and look at Mare Charisma, and now you're going to see that, not that one with some real crispness to it there. There's your bear. It's right there, up in the right-hand corner.
I don't see the bear. I don't see the bear.
Oh, give me a break.
No, I see Wilma
You're not
Flintstone.
even on the right part of the moon. You're the one
I
there.
still can't even see the man in the moon, so it's
To the
okay.
right, to the right, to the right.
I see the dinosaur. There's
No, you're
there's
going the
his
wrong
head
way. Go to the right.
over here.
Up, 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 up. No, you're going down.
The
Go
black
up.
circle with the two dots.
I'm going up.
And now go to your right. Now go down. On that.
There you
bear.
go.
Mare Charisma. That looks like a bear.
Oh, right there.
Two eyes and the nose. Right there.
There. That's
See,
what
you
you're
got the 2
saying.
ears.
Okay.
That's a
Yeah,
bear
okay.
sight right there.
Okay.
You see it
I'll give you
now?
that one. I'll give you that one. I
Looks
see
like
Wilma
a crab to
Flintstone.
me, but hey.
Now we got a bear on the moon. We got a bear on Mars. You can bear that?
Look, Wilma Flintstone. There's her eye. There's her mouth. There's her hair. She's
That's
wearing
it.
a diamond bracelet or diamond.
I'll have to grin and bear it.
Yeah, grin and bear it. Okay.
That was fun.
And if you have any images to send us, we love getting them. Send them please to astronomybythebay@gmail.com. I'm getting people to send them all to one address so I can pick them all up there. And that's our photos for the week.
And Renat said it looks like a ground squirrel.
It does. Okay. Let me see what I got for okay, so we got some closing comments, and I guess so before we do close out tonight, we wanted to mention our talk for next week. Kurt Nason will be back joining us again. He's going to have a look at his selection for constellation of the month. I know which one it is, but I'm not going to give it away, so I want you to tune back in. So in closing then tonight, we want to thank you once again for your continued supports of our efforts here. Our special thanks as always to Rosanna for her continued contributions to our program. Rosanna, we really do appreciate it. Wouldn't be a show without you. Thank you. We also hope that all of you who've joined us from Rogers enjoyed the program tonight. If you would like more information about the wonders of the night sky, you can contact me at astronomybythebay.ca. Also, special thanks to all of you who share our program. We appreciate it, especially Trudy out there who shares it a thousand times for us. Remember, we do love getting your photos, so send them in to astronomybythebay@gmail.com and we'll be happy to include them on our next broadcast. Now, if you have suggestions for a topic for a future show, please let us know there as well. And please let your friends and family know that we will be back here next Sunday night at 8 p.m. on YouTube and Facebook to entertain you on astronomy and the wonders of the night sky. So for now then, from Mike and Paul and I, we wish you a safe week, everybody. Lots of clear skies. Well, at least tomorrow night we'll have a clear sky. It's been a rough month. And as we like to say, open your eyes to view the skies and keep your scopes pointed up.
Yep.
Good night, everyone. Thanks for joining us.